Hello friend, welcome to Study by Technologies, and in our today's session we are going to discuss about conservation of momentum. First of all, what is momentum? We have already seen that whenever a body which is moving with some velocity has some momentum, and this momentum is actually defined as product of mass and velocity of the body. Alright, so we can write it like m into v. Now, how this momentum is conserved, or what is the law of conservation of momentum? Like, whenever two bodies interact with each other, their momentum remains constant. How it happens? Let's take an example here. Let's say I have a truck over here and a car over here, right? Let's say this truck is moving with some velocity v, and the car is stationary at that point of time. That means the velocity is 0. Okay. Now let's say the moment this truck hits the car, then what will happen? This car will start moving in some direction, and velocity of truck will also decrease. So what does it mean? Like in this case, some velocity or some momentum has been transferred from this truck to the car. That's why its velocity increased from 0 to some value, right? In the same way, some velocity from truck has been decreased. But what happened is actually the amount of momentum which is decreased from the truck has been increased in the car. So the total momentum before the collision and after the collision is conserved. Right. So the law of conservation of momentum states that when two or more bodies act upon one another, their total momentum remains constant provided no external forces are acting. Okay. So now let's go ahead and check it out with some example. Let's say I have a truck and a car. Okay. Here mass of truck is, let's say, m1, and that will remain constant obviously, and mass of car is m2. Alright. Now initial velocity of truck and car. Let's talk it about initial velocity. So initial velocity of truck is u1 and initial velocity of car is, let's say, u2. Fine. Now after the collision, let's talk about the final velocity. So the final velocity of truck has been changed to v1, and for the car this has been changed to v2. These two are after collision. alright, after collision. Now let's discuss about this. First of all, let's say car is acting some force and truck is also acting some force. So now let's talk about the forces that is being acted upon each other. The truck is acting force F1 on car, and as we know that if truck is exerting some force on the car, so the some kind of force will be exerted on the truck as well through the car, and that will be, let's say, F2. Okay, now let's go ahead. So let's say the force act F1 force acts on the car by the truck at the time t, and at that time the velocity of car changes from u2 to u1. In that case, acceleration a2 by the car, this can be given by change in velocity. Change in velocity means we have final velocity minus we have initial velocity upon time t, right? This is the acceleration of car when it is being hit by the truck. Alright. Now, who is exerting this force? This force is exerted by the truck. So we can say that force exerted by truck that is F1 will be equal to m1 mass of car into v2 minus u2 upon t. Alright. Now, when force F2 of this car reacts on the truck at that point of time, then there must be some change in velocity of truck as well, and let's say this will be a1. So this will be final velocity minus initial velocity upon t. Alright. Now the force will be equal to F2, and that is exerted by the over this truck. So that will be m1, that will be v1 minus u1 upon t. Alright. Now as we can see here that these forces which are being acted upon each other, these are like F1 is actually equal to minus of F2. Why? Because these are being acted on each other in opposite direction. Let's say F1 is being acted by this way and F2 will be in opposite direction. So that's the reason they will be treated as negative. Now let's write that expressions. M v2 minus u2 upon t, and that's equal to, yeah, this is, let's say, m2 will be equal to m1 v1 minus u1 upon t, right? So we can say that this m2 v2 minus m2 u2 will be equal to m1 v1 minus m1 and u1. Okay, now we can interchange the positions, and it says that m1 u1 plus m2 u2, this will be equal to m1 v1 plus m2 v2. Right, now this part, momentum before collision, momentum before and this part is momentum after collision, and we can clearly see here that both of them are equal to each other, and that means the total momentum will remain conserved. I hope the concept is clear to you. Feel free to let me know in case if you have any further doubt or queries. Have a nice time. Take care of yourself.